Earlier in these videos, I mentioned that you can't mix types like option, try, and either inside of for expressions. And I want to show you what I mean. So I have some code here in the book. And what I'll go ahead and do is show this in the REPL. So the first thing I do is just import a couple of things that we'll need. So primarily I just need try here, and I need all catch, which I've shown in the previous lessons. So next what I want to do is just start creating some functions that we're going to use. So this one's called makeInt option, and it's going to return an int inside of an option, and I use all catch just like I did before. This one's going to be called makeInt try, and very similar to the previous function, except that it uses try instead of option. And then this one's called makeInt either, and it's going to use the either data type here instead of option or try. And now what I want to show is that you cannot do this. So what to do? So we could try to do I, and we would say makeInt option there. And let's just give it a 1. And we can even use values here that will succeed in other situations. So that will be a 2, and then K will be the makeInt either. So what I'm trying to do is combine option, try, and either inside of here. And now we can say, well, what I want to do is I want to yield I plus J plus K. So what I'm trying to simulate here is you could imagine that you got this function from one vendor or from one programmer. You got this function from another vendor or programmer, and then you got this function from another vendor or programmer. So they all preferred different types. So one person preferred to return option, somebody else preferred try, someone else preferred either. And now because their code is so good, you want to try to mix these three together here inside of a for expression. And in short, what happens is that fails. And I want to show that this will fail. Even if you just try to mix option and try, this will still fail. So the reason I did that was you might think, well, you just can't mix an either or a try here because of what that error message said. But the reality is you just can't mix option, try, and either inside of a for expression. So that's what I show here. When I just try to mix option and try, you'll see that those fail just like that. So now if I come back over here to the book and go to the next page over here, one thing to say is that I explain why these don't mix in my much larger book, Functional Programming Simplified. So this book that I'm showing you right here is called Learn Functional Programming the Fast Way, and it's only about 250 pages long. The print version of Functional Programming Simplified is over 700 pages long, and the PDF is over 1,000 pages long. So that's why I'm not getting into some details in this video. And really, the only important thing you need to know is you just cannot mix these types inside of for expressions. But what you can do is mix as many I/O data types inside a for expression as you want. So now I can come back over to the REPL here and demonstrate that. So the first thing I need to do is use these two statements here. So this one says I want to use this library. And if I hadn't already used that today, it might have gone out to the internet and downloaded that for me. That's what this import does right here. And then in this one right here, I'm just saying that I want to use all of the classes and data types and functions and anything else that's inside this high-level ZO package. And also, you didn't have to watch me type all this. I copied and pasted this code in. So what I do in this example is this is the equivalent of an option right here. That's a sum of 1. This one is a try value right here. And this one is an either value right here. That's the success value in an either. And what I do in each one of these lines over here, you could think of this as wrapping each one of these inside of a ZO. So now I have this ZO, this ZO, this ZO. And what I'm doing is returning that right there. So when I hit enter, there is no failure. There is a lot of output here, but none of that is a failure. And what you see inside of here is, again, a data structure. So res is the variable that I created right here. And res, at this point, all it does is contain this data structure right here. There is no failure, and it just consists of this data structure. And you might not believe me that this actually works. So what I'm going to do is take another step. So bear with me just a moment. So what happens here is if you actually want to run a type like res inside of the Scala REPL, you have to import these other utilities right here. So this is something someone created. I believe it was Adam Fraser that created this, and I will double check that when I edit this video. But basically, you have to add this into the REPL so you can actually run a type like res, because really it is just a blueprint right now. And unless I import these things right here, I won't be able to look very easily at what's inside of res. But now that I have it, I can just type res, and then I can say unsafe run. And unsafe is an interesting word because what's going on is everything inside these ZEOs is considered unsafe. So you can imagine that this first one is something that goes out to get some kind of REST service. This one hits a database. This one does something else like write to file or read from a file. So all those things are considered unsafe. And that's why nothing is run until you issue this function down here, unsafe run. So that's where the word unsafe comes from. I just want to let you know that. So now I'm going to run that. And we see that the result is 6. So again, we quite literally, with this code right here, we quite literally created a blueprint, or if you prefer to think about it, we created a data structure, and absolutely nothing happens at that time other than creating that data structure. And then this exists as that blueprint or as that data structure until this unsafe run down here. One thing I should add is that when you write a ZIO application, a real ZIO application outside of the REPL, you won't see this unsafe run part. All you'll be doing there is defining a run function or a run variable, and I'll show you that in the upcoming ZIO lessons. And then let me come back over to the book here for the summary. So again, option, try, and either don't mix well. You can't use them inside of for expressions. And that's where types like ZIO come in, so we can start doing things inside of for expressions. And the important thing I should mention about for expressions is that they let us do things in sequence. So a for expression lets me say, I want to do this first, then I want to do this second, and then I want to do this third. And that's a very important part about for expressions that I haven't emphasized yet, is that they let us do things in this sequence. So if it's important to do things in sequence, like get information from the outside world here, check that against the database, and then return a result here, that's where for expressions come into play in functional programming, is that it allows us to do these things in the proper sequence. So that's why I'm spending this time to emphasize for expressions, because when you get into larger code, you'll be using for expressions a lot to sequence code like this. Another thing I mentioned up here is composing values or composition. And that can be a big problem when you're trying to compose types like option, try, and either. But here with ZIO, you can see that we can compose all those together just like that. Another thing I want to mention too here is let's import some things that we need for a future. I just mentioned that a for expression allows us to do things in the correct order, and a future is a way of showing that. So a Scala future lets you do things concurrently. It's a way of basically spawning a thread, if you want to think of it that way. So it spawns a thread and it goes off and does some work. I could fill this up with 5 or 10 different futures in here that actually go out on the internet, to do things over here and then come back with results. And if the order in which those things are done is important, then you want to run them inside of a for expression like I'm doing right here. So I'm just doing this to show a couple things. One is that you can mix a future with these other types right here. And another one is that if you had futures and you wanted to make sure that they were done in a certain order, you would want to do them inside of a for expression like this. So I'll just hit enter. And again, you'll see that the blueprint worked. And then if I do the same thing with res.unsafe run, you'll now see that new result right there. So again, I feel like I'm emphasizing this a lot or maybe overemphasizing this, but you'll use for expressions in functional programming with ZIO and with cat's effect when you want to make sure things are done in a proper sequence. The last thing I show in this lesson is that IO types have been created as a way to deal with IO and basically all other side effects. They have all the benefits of option, try, and either, but they're lazy, and that allows us to keep the algebraic substitution model. Again, we're just creating blueprints over here. They can also be combined in for expressions, which I just showed you over here. And once you go into the ZIO documentation, you'll see that they have many more features than these other error handling data types. So as I've mentioned, option, try, and either, if you were to write those from scratch, you could literally write each one of those in less than 1 page of code. But a type like ZIO has been written by many developers over many years to create all of the functionality that it has. So, given everything we've covered and all these lessons leading up to here, The next lesson is going to be about how to start using Zio. So you see down here, we'll start creating Zio applications in the next video.